Good morning, students. In the last video lesson, we studied about the mixtures, the impure substances around us. We also discussed the classification of mixtures on the basis of distribution of the components and its particles. Today we'll continue with the mixtures only, but the three types of mixtures, solutions, colloids, and suspensions on the basis of the other physical properties, like for example their appearance, solubility, stability, filtration, the particle size, etc. When iced tea mixes dissolve in water, it forms what kind of mixture? Of course, homogeneous mixture. When substances dissolve and form a homogeneous mixture, the mixture is called a solution. Whatever substance there is more of is called the solvent and the other is called the solute. Here in the example, iced tea, the solvent is the water and the solute is the tea mix. There are n number of solutions around us. We commonly use salt solutions, sugar solutions, glucose solution in our daily life. When we discuss the mixtures and solutions, both are formed of two or more substances mixed together. But the substances can easily be separated in case of mixtures, whereas the substances cannot be easily separated as the combination is a new one in case of solutions. We can have 1 to 2 methods of separation on the basis of physical properties of mixtures. But for solutions, there are more than 2 methods of separation required on the basis of physical properties of solutions. When we consider the solutions, solutions may be gases, liquids, or solids. An example is solution of sugar in water. A solution is a homogeneous mixture where a solute is dissolved in a solvent. Solute is the substance being dissolved. Solvent is the liquid mostly in which the solute is dissolved. An aqueous solution has water as solvent, since water is known as universal solvent. How can we prepare a solution? When we take a solute, which is a substance that is dissolved in a solvent, and stir well, then we get a solution as a result of dissolution of solute in the solvent. Parts of a solution. There are basically two parts. Solute, the part of solution that is being dissolved, usually lesser in amount, and second, solvent, the part of a solution that dissolves the solute, usually the greater amount. The two combine to give us solution. We can have n number of examples which include air in balloon, ammonia water, rubbing alcohol, tincture of iodine, and seawater. If we consider the solutes are oxygen, ammonia gas, water, ethyl alcohol, iodine, and salt, whereas solvent includes nitrogen, water molecule, isopropyl alcohol, water molecule again, alcohol, and water. Since solvent can be water as well as other substance, other liquid, hence we do have types of solutions also. Thus, we can say that solution is the mixture formed when a substance dissolves. The substance that dissolves is solute. The liquid in the solution is solvent. The process of mixing of a substance in a liquid is dissolution. When a substance dissolves completely, then we call it a soluble substance. And when a substance does not dissolve completely in a liquid, then we call it as insoluble substance. Even though most solutions are liquid, solutions do exist as solids, liquids, and gases. The first one is the example of solid alloys. Brass, bronze, steel, stainless steel are the alloys. Mixture of two or more metals, or a metal and a non-metal, which cannot be separated into their components by simple physical methods. An alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. Like, for example, brass. Brass is a mixture of approximately 30% zinc and 70% copper. Second one is the example of liquid showing tincture of iodine, where iodine dissolves in alcohol. Third one is the example of the gas as solution, air, which is a mixture of various gases, mainly nitrogen, oxygen, carbon dioxide, water vapor, etc. Solvent and solutes do sound similar but may have differences in them. And these are: solvent always is considered as the component, the liquid phase where the other things are dissolved, whereas solutes can be the solid, liquid, or in gaseous phase. A solvent is a substance in which different compounds, components can be dissolved, whereas a solute is a substance that can be dissolved in the solvent to form a solution. Solubility depends on the solvent properties such as its polarity, whereas solubility depends on solute properties such as surface area of the solute. Larger the solute, greater time will it take to dissolve in solvent to form the solution. Some substances readily combine to form solution, whereas others do not. So such substances which dissolve in a solvent are said to be soluble, whereas substances which do not dissolve in a solvent is said to be insoluble. Sand and water, though form the solution, sand remains as insoluble in water, whereas salt and water forms the solution. Here, the salt completely dissolves in water and is soluble. When a liquid dissolves in another liquid, it is said to be miscible. Whereas when two liquids do not dissolve and form separate layers, then are immiscible liquids. Water and alcohol, acid and water, bases and water are the example of miscible liquids. Oil and water, kerosene and water, petrol and water are the example of immiscible liquids. Classification of solutions. Solutions that contain water as solvent are aqueous solutions. Solutions that contain a solvent other than water, such as ether, benzene, petrol, carbon tetrachloride, etc., are non-aqueous solutions. Aqueous solutions are homogeneous mixture that are prepared by dissolving a solid, liquid, or gas in the aqueous medium, water. Whereas The solutions obtained by dissolving a solute in any solvent other than water, the non-aqueous medium, benzene, alcohol, ether, carbon disulfide, carbon tetrachloride, acetone, etc., are non-aqueous solutions. Cola, seawater, rain, sugar solution, acid solutions, base solutions, salt solutions, etc. are examples of aqueous solutions. It allows the solutes to ionize in water and conducts electricity. Hence, these are the examples of homogeneous mixture capable of being dissolved completely in water. Non-aqueous solution, on the other hand, can be having various advantages. Organic acids and bases that are insoluble in water are soluble in non-aqueous solvent. Organic acid, which is of comparable strength to water, can be titrated easily in non-aqueous solvent. If the drug is not completely soluble or stable in aqueous medium, it may be necessary to use an alternative non-aqueous solvent. Oily solutions of drugs are often used for depot therapy, particularly in muscles, and here non-aqueous solutions are used. The solutions further are classified as saturated, unsaturated, and supersaturated solutions. When the solvent holds as much as solute possible at that temperature, dissolved solute is in the dynamic equilibrium with solute present in it, then is the example of saturated solution. Unsaturated solution to have less than the maximum amount of solute for that temperature is dissolved in the solvent. Whereas solvent which holds more solute than the normal possible solute in it at given temperature is supersaturated solutions. These solutions are unstable and crystallization can usually be stimulated by adding a seed crystal or scratching the side of the flask. An unsaturated solution is the solution in which more solutes can be dissolved at a given temperature. A saturated solution is the solution containing the maximum amount of solute that will dissolve at a given temperature. A supersaturated solution is the solution that contains more solute than would dissolve in a saturated solution at a given temperature. Whereas solutions can be also dilute and concentrated on the basis of amount of solvent in it. If solvent is less, whereas solutes are more in amount, the solutions are concentrated solutions. Whereas if solvent is in more quantity than the solutes in it, then the solutions are known as dilute solutions. We can find the concentration of a solution by two methods. First, mass by mass percentage of a solution. If we know the mass of the solute, mass of solution, can divide both and can multiply by 100 to find out mass by mass percentage of a solution. Mass by volume percentage of a solution can also be obtained by having the mass of the solute divided by volume of solution into 100. Two examples of numericals are here, where first one is having a solution of 50 gram of common salt in 450 gram of water. So what should be the concentration of the solution? Concentration of the solution is equals to the mass of solute divided by mass of solution into 100. Solute here is 50 gram. Solvent here is 450 gram. Hence, mass of solution is altogether 500 gram. Concentration therefore will be 10%. In example 2, 4 gram of a solute is dissolved in 40 gram of water to form a saturated solution at 25 degrees Celsius. So what should be the solubility of the solute at 25 degrees Celsius? Solubility will be the concentration, which can be calculated by mass of solute divided by mass of solvent into 100, which is 10 gram. Solubility is the ability for a given substance, that is solute, to dissolve in a solvent, and it is affected mostly by temperature and pressure. As the temperature of a solution increases, the average kinetic energy of the solvent molecules increases. Thus, solid and liquid solutes become more soluble and dissolve more rapidly as the temperature increases. The solubility of gases in liquids decrease with increasing temperature. Gases tries to escape when temperature increases as the kinetic energy is increased. Therefore, oxygen carbon dioxide gas content decreases in hot water and harm aquatic life. Pressure. For solid solute, as pressure increases, solubility remains the same. Whereas for gaseous solutes, as pressure increases, solubility also increases. Nature of solvent. If highly soluble substances are present, then solubility will be high. If insoluble substances are present, then solubility will be low. Second type of mixture is colloids. A colloid is a substance microscopically dispersed throughout another substance. The word colloid comes from a Greek word kolla, which means glue. Thus, colloidal substances are glue-like substances. These can be made settle by the process of centrifugation. The particles pass through the filter paper, as these can pass through semi-permeable membrane and cannot be separated there. Every colloidal system or solution has two parts, a dispersed phase and a dispersion medium. The dispersed phase particles have a diameter of 1 nanometer to 100 nanometer, whereas the particles are normally invisible in an optical, though their presence can be confirmed with the use of ultramicroscope or electron microscope. A dispersion medium is the medium which is a continuous one where the dispersed phase particles are present. Examples of colloids are milk, synthetic polymers, fog, blood, jam, shoe polish, smoke, etc. Based on physical state of dispersed phase and dispersion medium, nature of interaction between dispersed phase and dispersion medium, molecular size of dispersed phase, and appearance of colloids, the electric charge on dispersion phase, the colloids further have been classified. But we have to only study the various groups of colloids on the basis of physical state of dispersed phase and dispersion medium, which are as follows. It can be solid sol, where the dispersed phase and dispersion medium are solids. Examples include alloys, cranberry glasses. The colloid can be sol also, where the dispersed phase is solid and dispersion medium is a liquid. Example, ink and blood. It can be aerosol, where the dispersed phase is solid and dispersion medium is gas. Examples, smoke, ice cloud. It can be gel, where the dispersed phase is liquid and dispersion medium is solid, like for example jelly and curd. Colloid can be emulsions also, where the dispersed phase and dispersion mediums are liquid, example milk and cream. It can be liquid aerosol, where the dispersed phase is liquid, dispersion medium is gas, and examples are cloud and fog. It can be solid form, where the gas forms the dispersed phase, solid forms the dispersion medium. Examples include pumic stone, aerosols. It can be foam, where the gas is the dispersed phase, liquid is the dispersion medium, and the example is shaving cream. It can be smoke also, where the dispersed phase, dispersing medium are gases, and it can be the gases around us. True solutions, or the solution which do have particles very small, are also known as molecular solutions, whereas colloids or colloidal solutions also do have particles small, but they can only be considered as a few other differences between them, which includes as true solutions is a homogeneous mixture containing two or more substances, whereas colloidal solutions are heterogeneous mixtures which seems to be homogeneous. True solutions are always transparent, whereas colloids are translucent. The size of the particle is either 1 nanometer in diameter or less than that in true solutions. The size of the particles ranges between 1 nanometer to 100 nanometer in colloids. Particles are invisible to naked eyes and cannot even be seen with the help of powerful microscope of true solution, whereas particles are invisible as well as not seen with our naked eyes in case of colloids, but are visible under powerful microscope. In both the cases, filtration do not separate the particles. Particles do not settle at the bottom of the container, but in case of colloids, particles settle down at the bottom of the container after centrifugation. Brownian movement cannot be absorbed in case of true solution, as the particles are very minute. Brownian effect or motion can be seen in colloids. Now the third, suspensions. Suspensions are mixtures in which insoluble particles are suspended in a liquid or a gas. Solute and solvent separate when left to stand. Solute particles mostly sink to the bottom of the container, hence are known as unstable. Light is unable to pass through it completely. Because of the large particles, the particles settle down. These items need to be shaken before use. Suspensions are heterogeneous mixture where particles settle down. Water particles are not strong enough to keep the other particles from settling out. Example, muddy water. Colloids and suspensions both are heterogeneous mixture. Colloids were seems to be like homogeneous but are heterogeneous, whereas suspensions are true heterogeneous solutions. Colloid particles are comparatively small, hardly 1 to 100 nanometer in diameter, whereas suspension particles are comparatively large and more than 100 nanometer in diameter. Particles can pass through filter paper of colloids. Particles do not pass through filter paper in suspensions. Particles can be seen with the naked eyes. in case of suspensions, whereas particles cannot be seen with the naked eyes only under electron microscope of colloids. Particles do not undergo sedimentation, whereas in suspensions, particles undergo sedimentation. Thus, on the basis of the particles and the size of the particles, the solution, colloids, suspension can be seen with the help of this diagram. Particles are very small in true solutions. Particles are intermediate in size in colloids, whereas particles are very large in case of suspensions. Solutions are made up of particles or solutes and solvents. The solvent part of the solution is usually a liquid but can also be a solid and gas. The particles are either the atoms, ions, or molecules which are very small in diameter. Hence, solutions are also known as true solutions or molecular solutions. Colloid mixtures are having particles that are not as small as a solution but not as large as a suspension also. Particles are intermediate in size. Suspensions to have particles and solvent larger in size, and these can be distributed throughout the solution only by shaking the mixture. This shows the comparison of the properties of solutions, colloids, and suspension on the basis of particle size, appearance, homogeneity, transparency, separation, and filtration. Since the suspensions do have large size of the particle, hence these appear cloudy, are heterogeneous with uneven distribution of particles unless striked or filtered, often opaque, can be translucent also, easily separate or settle down, and particles do not pass through filter paper. Colloids do have particle size between 1 to 100 nanometer in diameter, also again looks cloudy, seems to be homogeneous but heterogeneous in nature, often translucent and opaque. It can be transparent also can be separated and pass through filter paper. Filter paper particles and pores are quite large enough to allow the particles of the colloid to go through it. True solutions to have particle size less than 1 nanometer in diameter, looks clear, homogeneous as the particles are evenly distributed, transparent, does not separate by filter paper. But another property is also observed in these mixtures. Solution, colloid, and suspension, when go through this effect, show a special scattering property of light. When a light source is kept in front of glass containing solution, colloid, and suspension respectively, we do see that beam of light is not visible in solution. It is visible in colloid with a scattering effect. It is also visible in suspensions but without any scattering effect. This scattering of light by particles of colloid and also sometimes by suspensions is known as Tyndall effect. John Tyndall was a prominent 19th century Irish physicist and had done several work. The visible path of light produced by scattering action of the particles in a colloid solution on a beam of light passing through it is Tyndall effect. Solutions do not show Tyndall effect as the particles are so small, molecular in size, that these reflect the beam of light. Hence, beam of light is not even visible in the solution. Suspensions, on the other hand, do have large particle size which settle down because of gravity being denser, hence do not scatter the beam of light but allow the light to pass through it. The particles of the colloid are only suspended in the solution, hence allow the beam of light to be scattered when enters. The scattering of a light beam when it passes through a colloid is Tyndall effect. This effect can be seen in the forest, where the water vapors present in the surrounding acts as the colloidal particles to scatter the beam of light of sun. It is also observed in a closed room where a small ventilator or a hole is present to allow the light to enter. The dust particles of the room of its air allow the beam of light to scatter and show the Tyndall effect. The light of the blue sky also show Tyndall effect. The dust particles, the pollen grains, water vapors present in the air scatter the beam of light of sun. Thus, today we have studied about solutions, colloids, suspensions. We discussed that solution is a homogeneous mixture with having small particles of the solutes which do not settle down when left undisturbed, hence is stable in nature. Whereas colloids are the heterogeneous mixture where particles are not too small to be individually seen by naked eyes, but by only with the help of electron microscope. Its particles can pass through filter paper and are quite stable. Whereas suspensions are heterogeneous mixture, its particles can easily be seen by naked eyes as are bigger in size. When left undisturbed, the particles settle down, hence is unstable. On the basis of this, you have to complete assignment 4. That is, the first is to find out the composition of alloys, the two which are very commonly used in our daily life in their percentage. Second one is to calculate the mass of water. You can say volume of water also, and the mass of glucose required to make 250 gram of 40% of solution of glucose. You also have to define dispersion medium and dispersed phase. Fourth is to write the reason why do we observe the Tyndall effect only in colloidal solutions. Third, next to it, by which technique of separation colloidal particles can be separated. And last, to find out 2 examples of miscible liquids and immiscible liquids. In our next class, we'll start with separation of components of a mixture on the basis of the nature of the particles, on the basis of the various components there. Thank you.